problem solving with selection. Okay, and we will start the tutorial number 4, okay, which deals with the repetition or the loop structure. Okay, let's remember the selection. So the selection is a structure that is based on condition. Okay, so we have to check a condition, and if the condition is true, okay, we have several blocks to execute, or we can skip, okay, if this condition does not meet. Okay, designing an algorithm and implementing a program. So how can we identify the need for selection in a program specification and express this in an algorithm? How can I identify this selection on an algorithm from the program specification? Okay, now we have program specification, and we need to identify, to know if I need some selection or not. Okay, so the first step is to check for the clues in the program specification for the words like if, okay, otherwise, depends on, okay, either it can be this, for example, instruction or another one, okay, decide, choose. There are a choice, okay, between different choices, whether, what, and so on. Okay, so all these words, and not only these words, okay, there are other words, indicate the likely need for selection. Okay. Okay, so they may appear on their own or in combination. Okay, it can be only one word, okay, or it can be a combination of these words, such as in the following sentences. If the ball hits the bat, okay, so play a beep sound, otherwise play a klaxon sound. Okay, so here we have two words, we have if and otherwise. Okay, if not, oil should choose to fly out. Which assignment do you mean, Mohammed? Which assignment? You have the quizzes and you have the TMA, okay? Only that. And the final, it will be on Compass, okay? It is not an online exam. It is the exam will occur on the Compass, okay? So you have only that. You don't have other assignments to do, okay? Okay, look here. Oil should choose to fly out of the cage if, okay, here we have choose to fly if fox is not nearby, okay? Or use a table of symptoms to decide whether the patient has a flu, okay? So there are some words that can help me to identify, to know that I need some structure of selection, okay? Okay, each of these sentences can be rephrased in a way that is more similar to the programming structure for selection. So this gives a clear guide in the algorithm. Look here, this sentence, this English sentence will be written in another way that show the selection, okay? The selection that is more similar to programming language. So look here, if the ball hits the bill, then play a beep sound, else play a klaxon sound, okay? If fox is not nearby, then oil flies out of the cage, okay? If the patient symptoms match those in the table for flu, then the patient has the flu, etc. Okay, so we can paraphrasing the program specification to have okay, a more similar sentences to the programming structure for selection. Okay, now we need, after that, after you write your algorithm, and you implement your program, you need to test and debug your complete program. So you learned what we aim to test every aspect of program specification. For a program does different things for different kinds of input, we need to test, okay? A test involving each kind of this input, okay? When you have several input, okay, and several kind of output, for example, or several kind for input, you need to test all of them, okay? So to illustrate, let's consider the tennis tournament example from activity 3.13. Participants of the tournament, okay, need to be entered in the right competition for their age as follows, okay? So we have 3 classes. We have those aged under 12 should be entered for the junior competition, and those between 12 and 18 should be entered in the intermediate competition, and those over 18 or over should be entered in the senior competition. So here we have selection on the age, okay? So as you can see here, we have some boundary values, okay? What are these boundary values? They are, okay, 12, 18, okay? This is the boundary values, okay? So figure 25, this is figure 25, illustrates that what the specification requires the program to do changes are the 2 key points, age 12 and age 18, okay? So look here, age 12 is not included in the junior competition. It is rather included to the intermediate competition, okay? 18, it is not included in the intermediate competition. It is rather, okay, within the senior competition, okay? So values where the program requirements change are called boundary values, okay? What does it mean, boundary values? It is the values when the program need to change, okay? Look here, from junior, okay, competition to intermediate, from intermediate to senior, okay? So when we test a program, we need to pay particular attention to these boundary values. This is because Boolean conditions, especially compound ones, can often be put together in several different ways, and it would be easy for a programmer to implement a condition slightly incorrectly, okay? So we can here, for example, if I say that the age is greater than 12, okay? Is strictly greater than 12, so 12 will be included here. But if I write it is strictly or equal, so 12 will be within junior. So I can make some errors here. So for example, they may mistakenly implement greater than 18 instead of greater than or equal to 18, okay? I can here define the age, it is greater than 18, okay? So I mean, when I write greater than 18, 18 will be not included, okay? And this is an error because here greater than 18, okay? Or equal, we have greater or equal. So either I use greater than 17, okay? Or I choose greater or equal than 18, okay? Is it clear? And after that, we need to test these boundary values. So when we test a program that should do different things accordingly to different inputs, we should include inputs that will detect this kind of error, okay? So we do that by choosing values exactly on which boundary value and close it on either side. So this is called boundary testing, okay? So, for example, in tennis tournament example, we should include tests with ages 11, 12, 13, okay? 17, 18, 19. We need to to have this age, okay, and to test these ages and to see the result if it is correct or no, okay. Common selection errors. What are the common selection errors? So when testing, if the program fails a test, when we need to look for errors, okay? We need to check what? So we need to check one specific kind of error to look. Okay. One specific kind of error is to look out for in a program, okay, involving selection is incorrectly implemented conditions, okay. This is the among the common errors, okay. You make some errors in the condition, okay, in the condition. So a small error in implementing a condition can lead to boundary value problems, okay? Another kind of errors in programs involving if then else blocks is implementing the if and then parts in a wrong way, okay? So this is another common errors, okay? So having completed this part, you should be able now to describe the task performed by a small or you build program involving selection, okay? You amend or create a small or you build programming involving selection to meet the specification. You can create now an algorithm involving selection to solve a problem and suggest suitable values for testing a small or you build against okay, a specific program specification and test and if necessary debug your own small or you build program involving selection, okay? So this is all about selection. Is it clear? Do you have any question? Clear questions? So this is all about selection, okay? Okay, let's move now to the tutorial number 4. So in this tutorial, we will deal with loops, okay, repetitions now. Okay, we see all about selection and conditions now. Which one? Which one do you need, Brahim? Tomorrow we'll have lab. Okay, already the last week we have trained on selection. Okay. So look to the recording of the last lab. Okay, move now to the block 2 and part 3. It is the loops. Okay, so humans may get tired of repeating the same thing. Okay, we can have some tasks, some actions, okay, to be repeated, okay, over and over. But computers are ideally suited, okay, to repetitive tasks. Okay, when you have repetitive task, you can do it easily with computer. Okay, so all programming languages include structures for causing instructions to be executed repeatedly, okay? And repeated execution is often referred to as repetition or looping, okay? It is called or referred as repetition or looping. So there are 3 general types of loop. There are 3 general types, okay? There are loops whose contents executed or can be executed a fixed number of times, okay? So here we will use repeat 10 times, repeat twice, repeat 3 times, 4 times, 100 times, okay? So we need to define this number of times here, okay? We have loops whose contents execute indefinitely, okay, forever, okay? So this is the loop that it will be used for this type of repetition. And we have some loops that whose contents execute repeatedly dependent on some Boolean condition. So here we have some condition, okay? And I will repeat this block until this condition is met, okay? So where you can find all these OU build looping blocks, you can find it in the control palette, okay? And with selection with this structure, okay, in the same structure, okay, in the same palette, control palette. Okay, look at this activity. So activity 4.1, this is the activity 4.1, which introduces you to a program involving conditional loops using the block repeat until, okay? So look here, repeat until. So this program will be repeated until what? Until touching the final line. This is the final line. So the tortu and this okay will be this program will be executed or run until this condition is met. Okay. So look now for the different loops. Let's begin now by the forever loops. So the forever block refers to as a forever loop, okay? And the forever loops, it is the loops whose contents run over and over indefinitely, okay? It will not be stopped, okay? It will be working forever, okay? So they are sometimes referred to as infinite loops through, though in fact they can be stopped, okay? Many programs you interact with every day use such loops, such as the web servers, such as your computer's operating systems, okay? All these programming, okay, or these programs will use the forever loop, okay? So the forever loops in OU build are typically used to implement tasks that should continue indefinitely throughout a program. Example, implementing continuous background sound, okay, or continuous spirit movement, okay. So you can use this block. So OU build implements loops that execute forever with the forever block shown in figure 3. This is the forever block. This is OU build. Okay, in the control palette, this is the control palette. You can have the repeat, the forever, and the repeat until. Okay, so this is the three type of loops. Okay, this is the forever. It will be executed indefinitely. This is it. This repeat. It will be repeated the number of times shown here: 5, 8, 7, 100, 1000. Okay. And this repeat will be repeated until this condition here is met, okay? So this is the flow chart of the forever, okay? So it will be looped, okay? So normally you cannot have, okay, any instructions after this loop, okay? Because this loop will be running, okay, and indefinitely, okay? So the forever is a boot block. It is called the boot block. Okay, it is the last block of one program. Nothing can be attached underneath it. Okay, nothing. Okay, so a flowchart illustrating the forever block is very simple as shown in figure 4. So this is the preceding block. And once you have this loop, this forever loop, okay, it will be the boot block. Okay. Nothing can be attached after this this block, okay? So the forever loop can be stopped in various ways, including when a stop block is run, okay? We can stop this enabled by stop, okay? You write stop block, enables a forever loop to be stopped intentionally, and the stop block takes one of the three possible input values as follows. So look at this stop. When you write stop all, it will stop all scripts in the program. Okay, when you write stop and you write here this script, okay, so it will stop just the script that contains this block. You have here, for example, several blocks. For example, this block and this block and this block. When you stop here, okay, stop this block, okay, this is stop, this is all. This is this script, okay? When you stop this script, for example, here, it will be stopped only this script, okay? When you stop other script in Spirit, this one will not be stopped, the others will be stopped, okay? So this is the difference between the stop values, okay? All will stop all the values in the program. Okay, are you with me? This script will stop just the script that contains this block, and other scripts in Spirit that it will stop all other scripts in the Spirit concerned except the one that contains the stop block. Okay, is it clear? Is it clear? Do you have any question? Any question? No? Clear? Okay. Okay, move now to the conditional loops. Okay, the conditional loops, what does it mean, the conditional loops? It will deal with conditions, okay? Okay, Malak, you can ask. Can you open the microphone for me, please? Okay, okay. Okay, raise your hand, Malak. Okay, Malak.
Assalamu alaikum, doctor.
Walaikum assalam.
Doctor, I have a doubt about something. I just registered the course at Thursday, but I don't know, I'm not sure if my name now with you or not. They send you an email or something, because I just now registered the class today.
Today?
Yeah, I just attended the class today because I registered at Thursday, before 2 days ago.
Okay, what is your problem now? You need to check
Because,
if
yes, because in
me or
yes,
other
please.
section?
No. I am with you. I am in this section, okay. But in
Yeah, you
on
need the recording.
yes, I am in this section, but I am not sure if my name now attend with your the other students' list name and the LMS. There is nothing about the courses that I attended. They still in elements. They said enrolled courses.
Okay, I will check. You can send me an email. Send me an email.
Yes,
to,
please. I want your email.
Just to.
I want your email, please.
My email is shown in the LMS. In the LMS, you can open the LMS. Your LMS. Okay. You can choose after that your course Tm111. And after that, you will see my email, okay?
Okay. Okay, no problem. Thank you, teacher, and sorry if I interrupt the course.
Okay, no problem. Okay.
Thank you so much.
Okay. Thank you. Good luck. Okay. Okay, let's okay, so in meeting 3, you met Boolean blocks. Do you remember the Boolean blocks? And how we can deal with these Boolean blocks, okay, and the conditions, and their use as Boolean conditions for if, okay, then, and if, then, else blocks, okay? So we have already seen all about the Boolean blocks, okay? Just as OUbuild can use a Boolean condition to determine whether or not to execute a particular set of instructions, it can also use a Boolean condition to determine whether or not to execute a loop's contents. Okay, it is the same thing. Okay, so loops that work like this are called conditional loops. What does it mean, conditional loops? Conditional loops means that you have some conditions to check, okay, and if these conditions, okay, are met, okay, so we can execute, okay, the instruction inside this loop block, okay. Otherwise, we will skip this loop. So OUbuild implements conditional loops with the repeat until block from the control palette, okay. And the flow chart illustrating the repeat until block is shown in figure 5. So this is the repeat until, and here we need to identify or to write the condition, okay. So look at these at the flow chart of this conditional loop. So when OUbuild encounters a repeat until block, it first checks the value of the Boolean condition. Okay, so this is the loop. Okay, you have one condition to check. Okay, repeat until the condition is met. Okay, so it will be repeated when it is false. The condition is false. Okay, when the condition is true, okay, the loop contents will be skipped and we will go to subsequent block. Okay, so look, keep it in your mind. When you have the repeat until, okay, you will check the condition. If the condition is true, you will skip all the loop contents. Okay, once the condition is false, okay, you will execute the loop contents. Okay, so if it is true, then the loop contents are not run at all, and OUbuild moves on to any blocks after the repeat until block. If it is false, so the loop contents are run from the first block to the last, and then OUbuild again checks the value of the condition. Okay, so all the loops contents will be executed, and at the last, the condition here will be executed again. Okay, once it is false, it will repeat the contents of the loop. Once this condition is true, it will be skipped and go to the subsequent or the blocks, okay, after the loop. Okay, so before each potential run of the loop contents, OUbuild checks the condition to determine whether or not to run the loop contents. Okay, this is why we need to check the condition. Okay. Okay, look now at this exercise. So write a loop to print the numbers from 1 to 10. So here the code can be implemented in OUbuild as shown in figure 7 and 8, which are equivalent. Okay, so look here. We can set a variable I to 1 and repeat until I equal to 11. So this, once I is equal to 11, this block will be skipped. Okay, will be not run. Okay. and say I for 1 second, say I to I plus 1, or I, this is the incrementation of I, okay? Or you can repeat the same with, until I is equal to 11, okay? But you can change I by 1, okay? This is, so this instruction, it is the same as this instruction, okay? The incrementation by 1, by 2, by 3, by whatever the number, okay? You can even to change the set I, and the I, you indicate the number here of incrementation, okay? Or you can change I by this number, okay? So the change by block provides a simple way of increasing or decreasing, okay? Change I by 1 or change I by -1, okay? Set I plus 1 or I minus 1, okay? So it is the same. So to increment variable I by 1, we use change I by 1. And to decrement a variable by 1, we use change I by -1, okay? Okay, is it clear? Okay, so depending on the precise requirements, it can therefore be necessary to consider carefully whether and how to ensure that loop contents are run at least once, okay? We need to check at least once, okay, the condition is false, okay? That is, that the loop's condition reports false initially. We need to begin by condition false, okay, to have at least one time, okay, once. Whether and how to ensure that loop contents are not run indefinitely, that is, the loop's condition reports true at some point, okay? So this is when you have related to the condition, okay? If from the beginning the condition is true, okay, so the inner or the loop will be never change, okay? Will be never running, okay? But we need once at least, okay, one time at least, that this condition should be false, okay, to run the inside the loop. Okay, what is your question, Saif? The I is valuable here. It is a number. It is a value, okay? I will increment the I by 1, and I will say I. 1, 2, 3, 4, 5, etc. until 10 or 11, okay? This is your question? Okay, so for the fixed loop now, fixed, you look here, we don't have any condition to evaluate, okay? We have a fixed number of repetitions, okay? So the repeat block, which refers to as fixed loop, runs the block inside the loop's contents a several number of times, okay, given by the value in its input box, which should be a non-negative integer, okay? So once the contents have been executed the specified number of times, the execution moves to the next block, okay? So here we have n times, where n is the input value here, okay? So this is the loop, okay? You need to, if you are asked in your TMA or in your FTHE to draw your flow chart, okay, you need to draw it with the right form, okay. Here we don't have condition, okay. So when we need some condition, we need to use this shape, okay, to mean that there are some condition, and we need to identify when I can do when it is false, when it is true, okay? It is the same thing for the selection. False, it means that you will execute this block. True, it will mean that you will execute the other block, okay? So once the contents have been executed the specified number of times, the execution, okay, will move on to the next block as illustrated in this block. So the repeat 10 block, for example, repeats the loop 10 times, and we will use the term iteration to refer to a single run as the loop contents, okay? It can be, it can be the iteration, okay? So here we have 10 iterations, okay? Okay, look now at these string pre-processing. So the text pre-processing refers to the manipulation of text or words by a computer. So you may need to be implemented in many different ways. Think of a word processor, for example, which given a piece of text may search for the first occurrence of a specific word or character, replace every occurrence of a specific word or character with another, insert a character according, okay, to particular rule. All these text or string processing, you will need the loop, okay, you will need the repetition, okay, even if it is the conditional repetition or the fixed repetition, okay. So insert for all invalid word, that is, for example, word that don't appear in the dictionary and so on. So all these types are used, will use iterations, okay, to finish this task. Okay, look at this example. So the activity 4.8 illustrates a code that applies the decorative effect to any word entered by the user, okay, with the stars, okay, added at the beginning and the end and between each pair of characters, okay. So look, for example, if you enter the word rover, it will print or it will be display, okay, rover with stars between characters, okay. So this is one way, okay, when we can use the repeat, okay. And here, look here, we use the repeat for fixed time. What is the fixed time? The fixed number, okay, of time. It is the length of word, okay. When you have some word, okay, you will go through this word, so you know the number of iterations, okay. So look here at this example, we can do it. Okay, look at this example, we can do it. So we can open the oil build. This is the oil build, okay. So here we need what? We need to decorate some words, okay. So we will choose one events. It can be when space key pressed, okay. I will ask the user to enter a word. Ask, okay, the user enter a word, okay. Okay, I will set a variable called word, set word to answer. Okay, so I will get the answer and I will store it in Word. Okay, are you with me? Is it clear? Which one it is not clear, Abdulaziz? Which one? The OU build? Is it clear now? Okay, I will ask the user for a word. I will set word to answer. Okay, after that, I will create another variable called star word, okay, or decorative word, star word, and I will set this star word to what? To star, okay. So each word will begin by star and finish by another star, okay, and set the position. I will also position. I will also to go through this word, okay. Define a position variable to go through this. So I will repeat now in the control palette. I will repeat how many times. It is the length of the word, okay. Length of the word, okay. of our, okay, and how what I will do, I will set what? I will set star word to what? To, I will join here the star word, okay, with what? With the letter, another join. Here we have the letter position. The letter here, it is not one, it is position of word. Of what? Of word. And here we will add the star, okay? Is it clear? So I will go through the word, okay? One character by one. I will set the star word to what? I will join it the star word, okay? For example, here it will begin by start. Here you have start, and I will join the letter position number 1, for example, the first letter. This is the first letter, and after the first letter, I will add another star, okay? Until I finish. Yeah, we can, yeah, we can set the position to 1, yeah. Sorry. We can set position to 1, okay? And here I will increment or change position by 1. I will increment the position to go through the word, okay? Is it clear? And after this, I will say the star word, okay? Okay, look now, enter a word, for example, here, rover. So this is your decorative word, okay? Space, Ahmed, for example, and this is your, okay, space, idea, okay, so this is, okay, is it clear? Do you have any question? Clear? Clear? Do you have any question? No questions? Okay, so this is the example of string processing and how we can use the repeat the number of time, okay? We can use the repeat until, okay? I go or I am at the last character, okay? We can use it. So tell me how we can, sorry. So tell me how we can say, okay, another way of solving, okay? Duplicate, this is the other way. Okay, so I will repeat, not repeat the number of time, okay? Repeat until the position is greater than the length, okay? So I can use this repeat, I can use repeat until, okay? Repeat until what? Until the position is greater than the length of word, okay? Another way, this is another way, okay? Are you with me? So here I will change by A. This is A. This is rover. Okay, so this is rover. Okay, the same. This is A, this is Sadia, okay, and the output of Sadia. This is A, this is Ahmed, okay, and this is the decorative Ahmed, okay. It is the same thing, okay. So you can see here we can have many ways to solve the same program specification, okay, but we have different way to use, okay. We can use repeat until, we can use repeat the number of times, okay. It is up to you, okay. Okay, so look here what we have already done in this string processing, okay. We will say we have set the position to 1, okay, and already the value of the word is rover and the value of the first position is R, and the initial value of the start word is, okay, a star. So I will add this value, it is R, and with the star. So at the end of the first iteration, I will have at the end of the first iteration, I will have this okay, this decorative, okay, this star word, okay. At the second, this one. At the third, this one. At the fourth, and at the 5, okay. At the 6, okay, I will go to the subsequent blocks, okay. So a variable such as position, look here, we have already used a position variable. It is called an index variable, okay, because it is used to index or to provide access to an individual item of data within a collection, okay. When you have a list or when you have a string and you need to go through this list or through this string, okay, you will use an index variable, okay. Here it is called position. Here the characters within a string are accessed in turn using their successive positions within the string, okay. So we say that an index variable enables a program to iterate over a string, okay. It means that to repeatedly step through the string characters, processing them one by one, okay. So this is the role of the index variable or the position variable that we have already defined, okay. With length of word as the loop's input value, the number of iterations is the same as the number of characters in the user's word, okay. So this is the number of iterations. I know the number of iterations. This is why I use the fixed loop, okay. The basic idea of using an index variable to iterate over strings characters, okay. So when you have one string variable, okay, and you need to go through this string character by character, you will use an index variable, okay. Is it clear? Is it clear what does it mean, an index variable? So it is quite easily adaptable, okay. So for example, to enable iteration, to start at a character further on in the string or finish at the character before the final one, okay. So whenever it is required to process characters in a string, a loop in conjunction with an index variable is often the way to proceed, okay, is often the way to proceed. How we can start at later character from, you can initialize the position of the length, okay, the number length of the word, okay, and I will decrement length -1, -1, -1, etc. Okay. So string and lists have much in common. Now look now at the list processing, okay. A string is a sequence of characters, each at numbered position. A list is a sequence of data, okay, items. It can be either number or string or a collection of data, okay. Again, each at a numbered position. You have seen that all will provide some similar blocks for each. For example, the block that report the length of a string or the length of the list. You have some block that report the character, a specific position in a string, and there is a block that report the item of the specific position at a list. Okay, so this is the similarity, the common feature between the string and the list. Okay. So suppose that you want to create a list called sentence and initialize it by a number of words entered by the user. Okay, so you will definitely use the add to block, but you don't know how many words so the user will want to enter. Now you need to ask the user to enter a sentence, and you don't know what is the number of words in this sentence. Okay, so you can use this, can be done with a repeat until. Okay, and you can use some condition for that in conjunction with what is known as a sentinel value. Okay, so you need to define a sentinel value here. Once the user enters the sentinel value, this loop will be skipped. Okay, it means that the sentence is finished. Okay, so sentinel value is simply a value used to indicate that the loop should end. Okay, it is very important. Okay, these things. When you need to ask the user to enter some numbers, okay, or some words or some sentences, okay, and you don't know how many numbers, or it is not indicated, okay, it is free for the user to enter one word, 2 words, 3 words, okay, so you will use a sentinel value. What is a sentinel value? It is a value used to indicate that the loop should finish. Okay, for example, the full stop. Okay, you will ask the user to enter some words, and if he wish to stop, okay, he will put some full stop. Okay, he will enter the full stop. Once you see the full stop, you will finish the loop. Okay, so this is a sentinel value. The user here enters this value to indicate that they have no more words to enter, then the loop stops. Okay, for example, repeat until word is equal to Q, is equal to full stop, is equal to A, whatever. Okay, so Q here is the sentinel value. Okay, it indicates that the user doesn't wish to enter more words. Okay, so check at this example. Look at this here. So here we will ask the user to enter the word you want to add, or enter Q to quit. This is the instruction for the sentinel value. Okay, and I will set the word to answer. Repeat until what? The word is equal to Q. Okay, and add word to sentence if. Okay, ask the user. Okay, and set word to answer. I will check if this word is different from Q. If it is equal to Q, I will stop. Okay, so this is, look here, so I can new spirit. Okay, I can use new spirit, for example, the apple. Okay, in this apple I will write this program. So I will use some events. It can be the green flag. I will ask the user to enter the word you want. Okay, or enter, okay, Q. Enter Q to exit or to quit. Okay, to exit or to quit. Okay, I will set the data. Sorry, it is called word here. So I will set the word here, word to answer. Okay, and I will define a list called sentences. sentence, okay. This is my list, okay, and I will repeat until, here is repeat until what? Until word and equal. What is equal? This is my condition. It is until word equal to Q, okay, to Q. When word equal to Q, I will exit, okay. So I will here add word to sentence, okay, and I will ask again. I will ask again. I will ask and I will set word to answer, okay. So look here, enter the word you want to enter, Q to exit, okay. So hello in Tm111 course, okay. Okay, so this is my sentence, and now I will write Q, okay. So this is my sentence, okay. I can here say my phrase, okay. So say what? I will join. I need to join several. I can repeat. Can use the repeat, okay. Repeat how much times? Repeat times. It is the length, okay. The length of the sentence. Say, join. Here I have other variable. It can be sentence. Okay. So say, join sentence. Sentence to what? To item. Okay. Here I have item. Insert item, and what here? Enter item position. So I need now position. Okay. Set position to 1. Okay. Set sentence. Set sentence. To what? To the first item, any item. Or you can use it, you can discard this one, okay. Join sentence. And I can join here with another space between them. Join, here I have space, and here the item, okay. And the item with position, okay, of sentence. And I will increment, change the position by 1. Okay, is it clear? Is it clear how we can show? So this is one way. We can use another way, okay? Clear? So look now. I need to begin by clear all, okay? Or delete all. Here, delete all, okay? So look now. When we begin by delete all, it will be initialized to 0, okay? It will be empty. And here, hello. In Tm111 course. Okay, so this is my sentence. Now I will use the sentinel value Q. Okay, so here. Okay, this is my answer. Okay, you can see here. Here I can enhance. I can improve my I can improve now. I will say at the end. Okay, but here I will just. Okay, I will set sentence to join. Okay. And I will say after that. Okay. So this is the way how you can test, you can debug, you can enhance, improve your program. Okay. So set sentence to join sentence. Okay, I can here set sentence to not 0, set sentence to the first item. Okay, item. Item 1 or item position of sentence and repeat. Can begin by 2. Set sentence to join sentence. Here I have for the okay, I say here sentence. This one. Okay, so we will try now. Look now. Hello. In Tm111 course. Okay, give the sentence value. Hello in Tm111 course. Okay, do you see that? Okay. Okay, is it clear? Is it clear now? So you know now the difference between the position, the index value, the sentinel value. Okay. Okay. So this is what happened in the last. Okay. So look here. Figure 14 visualize how code works with input. Okay. For example, here you need to ask the user T for 2. Okay. Okay, and after once you enter the sentinel value, okay, the entering, okay, of input will be stopped. Okay. Okay, so a list allows the collection of data to be stored together and processed together. Loops can be important tool in enabling user input to be stored in list and also in processing data held in list. Okay. So of course, just as with strings, considerable variation is possible. So for example, a list may be iterated over in inverse order by using an index variable whose value decreases. Okay, I can begin by the last item and I can decrement the position. Okay. Once a list holds a collection of numbers, the numbers can be processed and looping techniques are often useful. So it may be required to, for example, to find the largest number in the list or the smallest number, to find the mean of the numbers, to list the numbers in orders from smallest to largest. Okay, you can do it. Okay, you can using this looping and these selections. Okay, structure. You can find the smallest, find the largest, you can find the mean, you can order the items in one list. Okay, so all these things you can do it. Okay, now, okay, so numerical processing with lists. Now, how can the smallest or lowest or minimum number in a list can be found in the list of numbers? Okay, how we can find it? Okay, find the list, the smallest or the min value. Okay, give me one way to to have or to pick or to find the smallest number. So one way is to set a variable called smallest number, okay? Say to the first number in the list, as is done in the incomplete script, okay? After that, compare the second number in the list with the value of the smallest. If the second number is less than the value, you will do the exchange, okay? You will set the smallest value to the second number and compare the third number in the list with the smallest number. If the third number is less than the smallest number, you can set the smallest number to this third number, etc. Okay, until what? Continue in this manner at the end of this list. And this is an example on finding the minimal temperature in one list of temperatures is given in figure 15. Okay, so note that the iteration should start at the second number in the list. Okay, because the first number is already, okay, assigned to the smallest number until the final number in the list. So this means that a list of n elements, there must be an n-1 iterations. Okay, if you have a list with 5 values, you will have at least 4 iterations. Okay, okay. So look at this example. So numerical processing with list. You have here. You have this is the example. So you have a list with temperatures. Okay, and you need to find the minimum temperature in this list. Okay, so this is your. So you need to create. In the first, you need to create your. So look here, we can use another spirit. It can be the temperature or the thermometer. For example, this candle, can use it. Okay. So this is my candle, this one. Okay. I will work here now. So in the first, I need to make a list called temperature. This list, I need to fill this list. So how can I fill this list? Okay, I can use, for example, I can ask you to enter the number. Okay, so I will begin by an event. It is when the space key is pressed. Okay, ask the user the temperature value, okay, or enter Q. Okay, I will set insert, not insert, add the answer, okay, to what? To temperatures. Okay, so I will ask the user. I can use here the repeat. Not if, it is repeat. Repeat until, not this one, repeat until what? Until answer is equal to Q, for example. Okay, I will repeat until answer is equal to Q. Okay, so here I will add answer two temperatures, and I will ask again. Okay. Okay, so this is one way how to fill, okay, your list of temperatures, and don't miss to begin by delete all here at the beginning. Why? When you need to enter other values, okay, you need to clear your list. Okay, so this is my list. Okay, after that I will find the smallest. Okay, so this is enter the value. So for example 20, 25, 10. And okay, I can hear D. Okay. So look here, when I D, enter the temperature 10, 20, 20, 84, to 57, and now I will enter Q. Okay. No, so Q will not be added. Here I have some mistake here. So I will, sorry, stop. This is G. Okay, 10, 23, 48, 2, 8. Okay, okay. So this is you all you need to debug. Okay, to see your errors. So my error is I have one space here. Okay, so this is why when I enter Q, it is not stopped. Okay, why? Because I need to enter space with the Q. Okay. So this is my error. Okay, this is my temperature list, temperatures list. I need to find now the smallest. How we can find the smallest? So I will define a new event. For example, here it is a G. I will define the minimum variable called minimum. Okay, minimum temperature. Okay, I will set the minimum temperature to what? To the first item, okay, to item number 1 of temperatures, okay, and after that I will repeat what is the number of times. We said that we have n minus 1, the length minus 1. I will repeat the length of temperatures minus 1. So I need this one, and here the length of temperature minus 1. Okay, I need to check if. So I need the selection if what? If the item, I need to compare now. Okay, I need some comparisons. Smallest, so it is lower than. If I miss something, what I miss now? I will go through the list. So I need some index variable, which is the position. Okay, so I need here the position. Yeah, good. The position variable. Okay, so here I will set the position. Set the position. Okay, to what? To 2. Okay, I will compare the item here position. Okay, of temperature with the minimum. Okay, the minimum temperature. If this value is lower than the minimum, okay, then I will set the minimum temperature to this item, okay, to this item, to the item position of temperatures, okay, and I will increment my position. Don't miss this step. And set or change, okay, position by 1. Okay, is it clear now? So this is how we can have the or pick or find the smallest, and after that I will say, okay, here I will join the minimum temperature is, okay, and here I will answer the minimum temperature. Okay, is it clear? Okay, so I'll press now G. So the minimum temperature is 10 here. Okay, this is my, it is not 10. Okay, let's D. 187 Q, okay, and after that I will press G. So here he tells me that, so there are no exchange, okay, there are some errors. What is the error? What is the error? What is the error here? The change is here, the change, okay, yeah, good, 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 the change here after the if, okay, look now, G. Okay, so the minimum temperature is 1, is good. Okay, so do you see how we can test and how we can debug and find my errors? Okay, is it clear now? So this is how we can see the minimum. Okay, I can use the maximum also. Make a variable. It is max. Okay, set here max. Set. It is the same, set max to item 1 of temperature, duplicate. Okay, if item temperature, then do that. I can have another if, control if, okay, and here greater, operator greater, duplicate, here max. Are you with me? And I will set this one, duplicate, here, change position, it can be after the if, okay, so this is the max, okay, so I at the last I can say the minimum, duplicate, okay, and the maximum here. Let's see, minimum temperature is, and here we will use the max, okay, with the same thing, okay, so this is a G. So the minimum temperature is 1, the maximum value temperature is 87, okay, so you see here, this is the minimum value and this is the maximum value, okay, so it is by the same way, okay. Have you any question? Is it clear? When it is inside the if, okay, so once the if is finished, okay, I will go through the repeat and I will repeat again, okay? We need not, it is inside the if, it is outside. Okay? It is not inside the if, okay? Okay. Okay, so how can the sum of the elements of a list can be found in the list of numbers now? We need to find the sum of the list. Okay, so we can have the mean, the max, the minimum, the maximum. We can calculate the mean. How we can calculate the mean? We sum all the items and we divide by the length, okay, the number of the items. So we will set for the sum, how we can sum the summation of all the items. We can set a variable called sum, okay, and we will set it to 0 and iterate on the list item one by one using an index variable, okay, add the value to the sum, okay. And if you want to find the average, so you need to use, or the mean, you need to use the formula average is equal to the sum divided by the length of the list. This should be outside the loop, okay. So example on finding the average to the temperatures is given in figure 16. Look now, we can find the sum of this temperature, okay. We can have the average, okay. So it is the same thing. We can add this portion, okay. So look here. So here we have already this part, okay. I can now add a variable called sum, okay. I will set the sum to 0. Here I will set sum to 0, or not to 0, to the first item like this, because here we will begin by the second position, okay. And I will repeat this number of times. Set sum, okay, set, we don't have any set sum to sum, okay, plus here I have sum, the summation, okay, already, plus here the item position, okay. Okay, so just this item, okay. At the last I can say the sum, the sum, okay, the sum of temperature is, okay, and here we will have not max, it is the sum. So this is a G, so the minimum is 1, the maximum is 87, and the sum is 125. Okay, if I need the average now, if I need the average, I need to divide the sum by, okay, I need now here the average, okay, average of temperature is, here I will do some division, so it is the sum, okay, divided by the length of the temperature, okay, the number of items it means, okay. So look G now, so this is the temperature one, the maximum, and this is the average. The average is 25, okay, the average, okay, is it clear? Do you have any question? Any question? Do you have any question now? Is it clear? Okay, so look, move now to the problem solving with loops. Okay, so this is how we can use the conditions, okay. So now we know we need to know what are the clues, okay, what are the keywords, okay. So what clues are there in a program specification that tell us the program may need to repeat something? How we can know that there is some repetition? So words like such as for each, or how many, or every, or until, or total, or while, okay, all these words may appear on their own or in a combination, okay, and it will refer to a repetition structure, okay? So these words may appear in their own or in combination such as for each child, okay, whose name in the list, get the age and the address of the child from the user. Or check the password to see how many times the space character is included. Or add the numbers together until the total exceeds 100, okay? Or play the music while the game is on, etc. All these words, these sentences can be reworded or reparaphrasing, okay, to use terms such as repeat, number of times, repeat until one condition is met, repeat forever, okay, which are similar to how you build programming structures for repetition, okay? So common errors in loops. Yeah, it is like this. Yeah, Malik, yes. You need to check the variables, to use the position, the index variable, to use the sentinel values, okay, to go through list to find the minimum, the maximum, the average, okay, to order the numbers, okay, you can be asked to order the numbers within a list or within a character, okay. So common repetition errors: if a test fails, then in trying to trace and fix a bug, it is useful to bear in mind common errors that tend to be made in programs on this sort of we are testing. Three kinds of errors specific to repetition are: a loop condition is incorrect, okay, so you need to check the condition, okay, you need to check if this condition, okay, is true or false, because when it is true, the content of the loop will not be running, okay, so you need to check if your condition at the first time, at least once, your condition is met, okay, is false. The data involved a loop condition is not changed correctly within the loop's iterations. An index variable is not changed correctly, like the position that we have made in the last activity with the loop's iteration, or is not initialized correctly, okay? These sorts of errors can lead to various problems, such as a loop not executing at all when it should, okay? Or executing indefinitely when it shouldn't, or accessing the wrong item, or attempting to access a non-existent item in a list or string, okay? So all these things, small slips, okay, in creating a loop condition, or manipulating an index variable often lead to either the first or the last item being processed incorrectly, whilst the other items are processed correctly. So you need to be in mind these type of errors, okay? So thank you for your attention, and if you have any question, you are welcome. Have any question? Do you have any question? Okay, what is your question, Hussein? Okay, thank you, Victoria. I think all the tutorials are. The final exams will be on Compass, only the final one. But for the quizzes, it is online, the quizzes, and your TMA will be also online, TMA, okay? So your TMA from 20 from 20 grades, okay, points, and your quizzes from 30, okay? So you will have 50 points online and 50 points in the Compass or at the Compass. Okay. Okay, thank you very much for your attendance.